Hello, good morning, Linear Algebra. This is coming to you from Anaheim, California. It is 4:40 in the morning right now, which actually works well for me because I'm trying to stay on East Coast time. It just makes my transition back easier, which means that Miss Bame and Mr. Runette are laughing at me when I say at 5 o'clock or 5:30 that I'm going to bed, because at home I go to bed around 8:30, 9 o'clock. Yes, Miss Yam needs her sleep. So the truth of the matter is that when I boarded the airplane to come here, I noticed that I had forgotten my multivariable calculus textbook, which means that I am just going to teach the lesson that I think would be most interesting, following the conversations that we've had. And then what I'm going to say to you is, hey, open up your book and see if there's a section there that's called local linear approximation or local planar approximation. But in any case, here we go. This is the starter, all right? Now, here's what you're told. You're told there's a function of x and y, and you're told the two partial derivatives right here, okay? And part A, and here's where all that work with equations of lines in vector form or parametric form will pay off from linear algebra. What I'd like you to do, please, is find the equations of the two tangent lines whose slopes are given above. So, and you can express these lines in vector form or in parametric form. Okay, I'd like the equation of the line tangent to the surface z at -1, 4, whose slope is 3. And I'd like the equation of the tangent line that is tangent to the surface z at the point -1, 4, whose slope is -2. And once you've done that, you can consult with someone next to you. You can either pause me now or you can listen with one ear as I kind of just tell you about the experience that I've been having here at this conference, which I'd love to tell you because you know that I can digress. So some of you know this. I think, Robbie, you know this, is that I am at the People of Color Conference. It's actually two conferences. It's called the POCC, the People of Color Conference for the adults, and then the students are involved in what's called the SDLC, the Student Diversity Leadership Conference. And I have to tell you, I think this is one of those conferences that I wish everyone had the chance to go to, especially you all, you students. And the conference name is, just to give you some background, the conference name is deliberately called the People of Color Conference because it's superficially, it's a place where faculty, adults within independent schools, okay, of color congregate as a majority, right, to discuss issues impacting faculty and students of color in independent schools. Now, that said, what's interesting is, you should know there are plenty of white adults and students here. And I'll tell you that, the conferences the workshops are so incredibly provocative and thought-provoking. One of them that I went to, I deliberately went to ones that would be, out of my realm of experience. I went to one on whiteness, and the title of that is, again, a very provocative title, but the topics there had to do with kind of deconstructing whiteness in America. What does it mean to be white? What does it mean to be a white person in this country? Particularly now, right, at this time in our current political state. What does it mean to be a white person who is questioning and thinking about how they become they're calling it an ally, right, or someone who is interested in thinking about how do you become a white person who does want to stand up and and engage in conversations about equity and inclusion and justice. The other one I went to, this is going to be interesting for you boys, is on masculinity and what does it mean for men who are kind of trapped in the social expectation of what it means to be male. The title is called Men and Self-Care, right? What does it mean to be a man who, if you think about just kind of the social and cultural expectations of men, there really isn't an expectation of men to take care of themselves, right? Or think about whether being a man, at least as society dictates it, is actually a healthy or good thing. So that one is about kind of deconstructing what it means to be male. And then girls, I went to one, I think you probably know this already, but body image is it's kind of a big thing for me. It's a big topic that I really feel very passionate about. So I've went to several on body image, particularly standards of beauty. And that's something that I became very aware of in my time at an all-girls school. I think the body image issues affect boys and girls. But I think if you think about it, the body image and the social ideal of beauty and the physical ideal of beauty for girls is one that's particularly harrowing. And as one Ellis student said to me, she said, asking a teenage girl if they have any body issues is like asking us if we breathe. Like, we may not all have full-blown anorexia or bulimia, but we have all, at one point or another, had kind of our body issues or body insecurities. So anyway, if you want to talk more, when I come back from this conference, I'm going to be brimming with the desire to talk about it, talk about these things. Maybe I'll have a kind of out-of-class informal discussion group. And I know the students here are going to do something like that as well for the student body. In any case, okay, so you have now done part A, all right? And then maybe you were listening to me with one ear and then going on to part B rather. Find the equation of the plane that is defined by those two tangent lines, okay? Now remember, when you have an equation of a tangent line, okay, and what is inherent in the equation of those two tangent lines is the vector parallel to the line, correct? Okay. Oh, you know what? You need one more. I'm so sorry. You need to know this. Sorry. You have to also know the z coordinate at that point. Yes, and I bet Max was saying as I was rambling on, Miss Yam, we can't do this yet. You didn't give us all the information. And yes, here it is, Max. I think I knew it would be Max. Max or Robbie. They're both so incredibly detail-oriented, and I think it's wonderful. They always catch me like, Miss Yam, you missed a negative sign or you missed a comma. So sorry. There it is. Okay? All right, once you've done that, then please find the equation of the plane that is defined by the two tangent lines above. What you remember from finding the equation of a plane is you need to know a point on the plane, okay? And you need to know the vector perpendicular to the plane. But the vector perpendicular to the plane is going to be the cross product of the two vectors here, okay, that are parallel to the lines. Now, actually, as I'm scanning this and as I was rambling on in my kind of sleepy state here, or just woken up state, I want to ask you this question. When you were finding the equation of the line, say, this line, whose slope is 3, right? Let me ask you, how did you find the components of the vector, okay, that was parallel to the line? Let me just stop there and let's answer that question. Once again, when you're finding an equation of a line, parametric or vector, okay, you have to remember that you need a vector parallel to, right? You need a vector parallel to that line. So the question that you may have is, wait, how did we find that vector? Well, I'm going to show you. Okay, and maybe as I was rambling on, and yes, I was rambling, but you know what, boys and girls, it's okay. You can deal some adult rambling, especially if it's thought-provoking things, okay? And, the other issue, too, is that the idea of compartmentalizing the way we learn, like math class should only be about kind of math as is defined in a textbook, and that there's no way to incorporate other modalities of thinking and consciousness. I have to tell you that I am vehemently opposed to that notion. Okay, so let's break this down. Some of you probably were stuck there, and maybe while I was rambling, one of you went and figured it out, and that's fine. And you may have muted me. That's fine. I don't take any offense. But I'm going to break it down for you here. Let's find the equation of this line, all right? So you know that the slope, and I'm putting it in air quotes because slope in 3 space means something different, right, is 3. Or as you like to say, 3 over 1. But this is, again, the change in z as a function of x. So if you think about that tangent line, right? So one point on that tangent line is the point of tan. So the point of tan is -1, 4, 7, right? And if you want, the point is we need a second point on that tangent line. The second point on that tangent line, right? The second point on that tangent line will allow us to then find a vector that is parallel to this tangent line. Well, the second point on the tangent line, I'm just going to use this slope here. If the point of tan is -1, 4, 7, and the slope, right, or the change in z as a function of the change in x is 3 change in z over a positive 1 change in x, what that gives me is the points 0, 4, 10. Okay, one more time. Why is it 0 and 10? Because it's positive 3 over positive 1. And maybe you're someone who's feeling a little bit, wild this morning. Maybe you want to say, well, couldn't it have been -3, -1? And sure, that could have been -3, -1, in which case you would have had -2, 4, 6. All right. Either way, however you swing it, you have to use this slope per se to find the second point of the tangent line. And then once you have these 2 points on a tangent line, you're able then to figure out the vector v that is parallel to this line. And vector v is going to be 1, 0, 3. Right? Now, I could have whipped through this very, very quickly. But maybe you now recognize and see a fantastic connection. This is kind of the beauty of doing things in a deconstructed way. Maybe you see a connection here between, oh my, this vector, and oh my, the slope. Yeah? Right? 3 over 1 is just 3 over 1. And so the other vector, if you want to find the vector that is going to be parallel to the second line of tangency, this one, right? Well, if you know that f sub y is -2 or just -2 over 1, guess what? The other vector, vector u, and this is, and maybe you'll write this down, right? Maybe you would write a little narrative story to yourself that this is the vector parallel to the line, tangent to the surface in the x direction, whose slope is 3. Vector u is the slope, is the vector parallel to the line, etc. Okay, but you know what this is going to be? It's going to be 0, 1, -2. That is vector u. Now you can find this the long way, right, by finding a second point on the tangent line, etc., etc. But hopefully this should make sense. Okay, now once you find the equation of those 2 tangent lines, maybe you're on to part B. Please find the equation of the plane that is defined by the 2 tangent lines above. Now, you need to cross v and u, crossing v and u. Now, if you look at crossing v and u, boys and girls, it's going to be a very easy exercise if you think about it, because look at the components of v and u. Crossing v and u will give you n. I'm going to let you just tell me what n is here, because I'm not going to find it, because you know how to do that. Oh no. When you find v and u, okay, when you find the cross of v and u, you're going to call that vector n. Vector n equals something, right? And then when you find, let's put over here, vector n is some point a, b, c, all right? And then when you find the equation of the tangent plane, what do you need for the equation of the tangent plane? You need n, and you need a point on the plane. Well, what's the point on the plane? The point on the plane is -1, 4, 7. It's the point of tangency, okay? So when you find the equation of the plane, it's going to be a times x plus 1 plus b times y minus 4 plus c times z minus 7 equals 0, okay? You will have found a, b, and c. So A and B, just kind of regurgitative algorithmic questions. Part C, conceptual. Is the plane from part B above here a function of x and y? Here's the key phrasing. Is your plane a function of x and y? Question mark. Be succinct in your explanation. Pause me here and have a talk about it. Remember what it means to be a function of x and y. Okay, what does that mean? All right. Okay, now, when you talk about the plane being a function of x and y, let's break this down. A plane would not be a function of x and y if it were parallel to either the zx plane or the zy plane, because if it was that, it would fail kind of our vertical line test, or the equivalent in 3-space, correct? Which I think we named it the pinhole test. So as long as your plane is not, I think as one of you may say, is not just, quote, straight up and down, right? And maybe one of you right now will get up and kind of hold a plane in the air. That would not be a function of x and y. As long as your plane is not, quote, straight up and down, it would be a function of x and y. All right? Now my question to you is, how could you tell very quickly whether the plane is a function of x and y? Yes, you would look at vector n, right? You would look at vector n, and what is the case about vector n that gives away whether your plane would be a function of x and y? Remember, vector n is perpendicular to your plane. Well, let's see. If vector n, right, let's write this down. If vector n, okay, if n is parallel to, flashback. If vector n is at all parallel to vector k, which is, by the way, 0, 0, 1, the standard basis, one of the standard basis unit vectors, okay? If vector n is parallel to 0, 0, 1, then you know your plane would not be a function of x and y, right? Then plane not a function of x and y. So boys and girls, you can take a look. Is a, b, and c a scalar multiple of k? Okay, my guess is going to be no, it is not. All right. Then express the plane as a function of x and y, please. Okay, so please take your equation of the plane right here and express it as a function of x and y. Oh my goodness, what does she mean? Well, guess what that just means in layman's terms? That just means take your equation of the plane and just isolate x. Isolate z. Just solve for z, right? So this is just algebra. When you go ahead, please take your equation of the plane and just solve for z. You're going to have z equals all this gobbledygook over here. And then you're going to call that a function of x and y. Oh, stop it, Yam. You know what? I can't use f. Goodness gracious, I can't use f. Why can I not use f? Because guess what? F has been taken. F describes this surface, right? So I'm just going to use g, right? Just like in 2-space, you can call a function f, you can call a function g. So I'm going to call that, once I find my plane, solve for z, I'm going to call it function g, which is a function of x and y. Look at that notation. Equals all this stuff over here. Okay? All right, so why all this buildup? Why do we just talk about this? Well, guess what? What you've just found here, this is called, this is the local linear approximation of f at, what was the point again? At the point, -1, 4, at the point -1, 4. Look at that. We just derived what it means to be a local linear approximation. You did local linear approximations in BC Calc and in AP Calc, BC and AB Calc. Back in the day, the local linear approximation was synonymous with the line tangent to f of x at x equals x naught, right? That's what a local linear approximation was back then. Now, the local linear approximation of a surface is the plane tangent to a surface at some ordered triple. That is your local linear approximation. Some books even call it local linear approximation. They also call it local planar approximation. I frankly don't like that because it just kind of dumbs down, I think, what it means to be linear in 3-space. Linear in 3-space is a plane. So this is kind of synonymous. But look at that. Isn't that a lovely thing? Now, there's a bunch of questions that now I could ask you. I could say, okay, if you have your local linear approximation, is the plane an over or under approximation? Remember all those questions from BC Calc? Is your linear approximation, is your tangent line an over or under approximation of f of x? Right? All that good stuff. Now, that is the lesson for today, and we approach this, I think, in a fantastic way, really. Now, here's what's going to get kind of funny. Is there a section in your book that is called local linear approximation? I can't imagine there wouldn't be. They may call it local planar approximation, but if it does, then my regard for this textbook just went down the toilet. But there should be a section called local linear approximation. And I guess what I'm going to say to you is, if there's a section, just pick some problems. Like pick, I don't know, what's a reasonable number of problems to take care of for classwork and homework? I don't know. Like let's just pick 8 problems to do. Now, I know you, and I know that sometimes you can be kind of in a sassy, naughty mood. So when I say pick 8 problems, ladies and gentlemen, please do not pick 8 that are like, I don't know. What is a local linear approximation? No. Pick a couple of those juicy true false ones, okay? Pick a couple that are just straight up plugging and chugging. And I think this text does a pretty good job of breaking down, like extend your understanding section, and then a true false section, and a conceptual section. So pick 8 and maybe do a, 2, 2, 2, 2, like 2 of the juicy extend your understanding, 2 of the second to last section, 2 easy, and then 2 medium, right? Okay? So, ew! Ah! Jesus. Largest cockroach ever. Oh, God. Oh, my God.